Good morning. This is Kavipriya, Assistant Professor, AC Department, SNS College of Technology. I am going to discuss about the topic counters from the subject Digital Electronics. So before exploring this topic counters, let's recall what is a combinational and sequential circuit. So the major chaos in digital system design is to understand what is a combinational and a sequential circuit. So combinational circuit is one which can process only the current input or present input, whereas sequential circuit is one which can process both the past and present input. So the sequential circuit is nothing but it is a combinational circuit with a memory element, and it is a basic for building the devices like registers, counters, etc. So these devices requires memory for processing the data. And this is my flow of presentation. I'm going to discuss about what is the need for counters and counters in day-to-day life, and what is a synchronous counter, and under the synchronous counter I'm going to discuss about the synchronous up counter, and finally about the applications of the counters. And what is this counter? So counter is meant for counting applications. So in day-to-day life, we have this digital clocks which is used for counting the seconds, and elevator is meant for floor indication, and microprocessor is one which can be managing the instructions, whereas industrial automations, the objects will be get counted. So the main drawback of humans is that they can't track the high speed events, which forms a basis for development of counters. And among the counters, what is a synchronous counter? So synchronous counter will be having a number of flip-flops. Each and every flip-flop will be triggered by the common clock pulses. So this eliminates a drawback in case of the asynchronous counter, where we won't be having a common clock pulse, which leads to the delay. This drawback is overcome in case of a synchronous counter. So compared to the asynchronous counter, synchronous counters are more fast and reliable. And types of synchronous counters are synchronous up counter, down counter, and up down counter. And among the types, I'm going to discuss about the synchronous up counter. Synchronous up counter counts in increasing binary sequence. For instance, let us consider a 3-bit synchronous up counter. So it starts counting from 000 and it ends to the point called 111, and after that it will be starts again from 000. So each and every change of state, it takes place at the negative edge triggering of the clock pulse. So the main advantage of the synchronous up counter is that it is very predictable in timing. And this is a logic diagram for the synchronous up counter. So 3-bit synchronous up counter. So we have 3 flip-flops over here. Each and every flip-flop is capable of storing the single bit of data. And all the flip-flops will be triggered by the same clock pulse. And the state starts from 000 and it reaches a 111, and again it starts from 000. So it keeps on repeating. And next we are using the flip-flop over here. The most commonly preferred flip-flop is a JK flip-flop. So we are using a JK flip-flop over here, and we know the characteristic equation of JK flip-flop is nothing but Q next is equal to JQ bar plus K bar Q. And we have 3 flip-flops over here. The first flip-flop will be toggled for every clock pulse, and second flip-flop will toggle only when the first flip-flop value is 1, and third flip-flop will be toggles when the second and first flip-flop value is 1. And this is the timing diagram. So we have this clock pulse, and Q0 toggles for each and every clock pulse, and Q1, the second flip-flop output, will be toggles for every 2 cycles, and Q2, the third flip-flop output, will be toggles for every 4 cycles. And finally, the applications of the counters, it is used in digital clocks and watches, and it is used in the frequency dividers to reduce the frequency signals, and it is used for entire control systems for controlling the binary signals, and it is used in modern counters. It's used for counting up to n states. And this is what a summary of my today's presentation. Initially, in empathy part, we have discussed what is a counter and what is a need for counter and what is a counters in day-to-day life. Under define part, we have discussed about the synchronous up counter, and under the ideate part, we have discussed about the characteristic equations and the diagram of synchronous up counter. Under the prototype part, we have discussed a timing diagram of synchronous up counter, and finally we have discussed about the applications of the entire counters. And next is an activity which is an puzzle. So it is like a match of following. Here the synchronous counter is meant for, in case of synchronous counter, all the flip-flops will be clocked together. Common clock pulse will be given to all the flip-flop. In synchronous up-down counter, it is a bidirectional count. It can count upwards as well as downwards. Modulo n counter is used for counting up to n states. Decade counter is nothing but it is a mod 10 counter. It can count up to 10 states. Starts from 0 and ends with 9, and again it will be starts from 0. And next is an assessment. A counter is usually constructed so it is nothing but it is constructed by using a number of latches which be connected in case of a cascade form. And types of counters are nothing but it is 3: synchronous up counter, down counter, and up down counter. And these are all my reference. The textbook is Maurice Mano and Sally Wagner. So that's all about today's presentation. I have discussed about the counters in depth. Thank you.